Okay, I guess we can get started. So everybody had lunch. So hopefully you're not too sleepy now. All right, my name is Andrus Adamchik, and today I'll be talking about Bootique and how to write containerless applications in Java. A few words about myself. And by the way, I'll be presenting in English, obviously, but if you have questions in Russian or Ukrainian, I understand those. I can answer. I'm an open source developer with for the last 15 years or so, and tomorrow will be my presentation on Apache Cayenne. So I'm a member of the Apache Software Foundation. I run a company called Object Style. I program in Java for the last 18 years, so it's been a while. I've seen lots of things happen and then die out, and then happen again and stuff like that. So today we'll be talking about something that I identify as Java paradox. This is something that I'm seeing over and over again when people who actually program in Java they don't like Java that much when they have a choice. And this is actually about people who are like really proficient with various aspects of Java. I'm hearing this during the interviews. I'm hearing this at conferences where people would say, okay, so at work I use Java, but then when I go home and I write some code, I do it in Node.js, so I have a startup and I'll never use Java because, and then like there's a list of reasons, you may have heard them and tried a whole different story about all the Java gripes. What I'm actually interested today, I'm interested in one of them, in containers. Have you ever thought that most of your work, and I'm not sure if you maybe, I don't know, these days you're working on Spring Boot 100% or something, but most of you probably still package your applications as wars and deploy them to Tomcat, Jetty, JBoss, or if you're unlucky, WebSphere, and so on. So containers are a part of our life in Java, and have you ever realized that what we call war files, we call them applications, but they're not really applications, they're just some kind of plugins. So they're no different from, say, like a plugin you write for IDEA or Eclipse. This means that they do not interact directly with the operating system. They usually, they have this pretty thick layer between your code and the operating system. So container creates this another layer of abstraction, and this creates all kinds of inconveniences. From not being able to, react to command line switches, for instance, inside your var because your var is not starting the Java process, to the need to have special plugins in your IDE, and your mileage may vary, and some of them are okay, some of them are not, and all those things. So, and then of course you have deployment. So you have another layer of infrastructure to maintain. You need special sysops people who know how to run your WebSphere container. So I'm looking at the evolution of Java to happen in waves, essentially. So we first start by, well, maybe not we, but maybe it's they, some people who are writing GSRs. We start with something, with some solution for a problem, and then we uninvent this solution in the following 2, 3, 5 years. And I think the same thing is happening with containers. It's just that the cycle is much longer. So it took 15 years to sort of build a critical mass of understanding and realization that containers are really obsolete. And it's not because they were bad to begin with. It's mostly because other things have appeared. Just all the cloud infrastructure, Amazon, Docker. So there are already many other things that we call containers these days. So we don't need a Java container. And that's a brave assertion for some, and that's just something that some other people already know that, essentially. So it's non-controversial for a big percentage of Java developers. So I'm thinking that cycle of uninventing a container is nearing its end right now, and there's a whole wave of technologies right now that allow you to just run your apps as apps. And it doesn't really take much to achieve containerless Java, really. So all you need is to go back to the basics, go back to your main method, right? But of course, if you remember how big your wars are, how many dependencies you have there, then of course you also have stuff that's on top of your war, so everything that container provided to you. Of course, you need to deal with that somehow. You cannot just throw it away. You can't start from scratch. So what is really happening right now is container inversion. So we just take our traditional Java architecture that contained applications within container, and we make applications that contain what used to be parts of container. So we rip it out, we put it in our apps. And again, this is all pretty simple and basic, but you still need some assistance to make it happen in a more complex environment where you need some kind of life cycle for all your parts of your app. You want them all to work together and in concert. So some help is needed, really. And before we start talking about Bootique, I wanted to mention something. All these new technologies, all the new containerless technologies, they appear and they're great and stuff, but nobody kind of had a term for the whole trend, for the whole thing that's happening right now. And I took a shot at that and I'm calling it Wheezy War, and that's just like a long unreadable abbreviation. Right. So what you see is what you run, and of course that's analogous to WYSIWYG. What you see is what you get. So this is a pretty standard thing that people are calling like visual development environments. So in this case, Wheezy War alludes to the fact that there's no intermediate layer between you and the operating system. So whatever you write in your IDE, it behaves the same way in your IDE as it will behave in production eventually. So what you see is what you run. Means you control your main method. You're no longer writing plugins. You're writing real apps in Java. So now we are getting to Bootique part. Among all the technologies that appear in this space, what is Bootique? And we call it minimally opinionated app launcher and integration technology. And of course, it underscores the main parts. First, we need an integration technology. So if we are writing something that is bigger than Hello World, right, we need to put a bunch of things together. We need dependency injection. We need life cycle. We need to know when the app starts, when it stops, and so on and so forth. And then we need all these modules to interact with each other also. So one module provides services to other modules. So we have an integration technology inside Bootique, and it's built on Google Juice. And we're actually thinking about alternative dependency injection systems and modularity systems, maybe Dagger, maybe something else. But right now it's built on Juice, and it works pretty great, actually. Also, it's an app launcher, because that's another thing that was traditionally not a part of Java world, Java culture, is integration with command line, essentially, because everybody in Java, they're doing it in their own ways, and very often it's just a bunch of -d property name equals something, right? So we want our Java apps to, from the start to behave as POSIX commands in Unix, for instance. That's a good standard to adhere to. So it's an app launcher that allows you to easily bind certain actions in your code to command line switches. And this is all pluggable, and you can change the style if you want to. And finally, it's minimally opinionated, meaning that unlike many solutions in this space, Bootique is not a stack that we give to you and say, okay, so you can write your microservices. So it's really a platform, and you can assemble your own stack using Bootique, and that's the whole point. This was the goal of the project from the start. The project is pretty fresh, pretty new. It got started in 2015, but I like to say that before we wrote the first code, we had 10 years of struggling with containers, trying to make the smallest possible Java container. So lots of experience in this area until we finally realized that, okay, so we just let it go. We just start from scratch. We do we go back to our main method. The project is a collaboration between my company and our client, National Hockey League in New York, and we're using it right now to switch a pretty big piece of NHL application code to a containerless approach, to WYSIWAR approach. So it's already been used, and there are some other people outside of object style and NHL who are trying that, and it's been really successful so far. Everybody likes it, people who try it. So now let's do a little demo to show how to write an app using Bootique. Okay. I have Eclipse. Hope nobody objects. Okay. Let me actually turn off internet because it'll just slow things down. Okay, so I have this little project, and let me go to the POM and actually make it a Java 8 project. So Bootique is based; it requires Java 8. We figured there's no point to support all the versions of Java; just really pointless. Okay, so we have that. We remove unit test for the moment, even though Bootique is actually pretty good at helping you write in integration tests. Okay, so we are on Java 8. We can actually start adding some meaningful dependencies. So Bootique is very modular. It is made of a bunch of small modules. One of them is a core, and others integrate with Jetty, whatever. So very different, many different things. So to actually remember what versions of which modules actually work together, we created something called BOM. So if you're using Maven, you probably know what it is. If you don't, BOM is a bill of materials. So that's just a single import that allows you to reference a bunch of interrelated versions. So we import Bootique BOM, and then we import Bootique core. So that's our first module. That's the core of the framework. And it drags with it Google Juice and a few other things, but it's not that big. Okay, let's go to our generated app class and replace Hello World with something else. So the minimal Bootique app looks like this. Bootique. So we use a builder to pass command line arguments because we need to interact with command line switches, and we call run. So we haven't added any code, anything, just pure Bootique core, and we can already run that. And of course, nothing interesting happens, but something actually did happen. It printed help, so it already behaves as a command line application and shows the functionality of that application. That functionality is just kind of circular. It can print help about help. But it can also take a config switch, which we will use a little later. Now let's recreate our hello world, but using Bootique. And one of the way Bootique app interacts with the command line is by you writing, as a programmer, writing commands. So let's write a command that prints hello world. Command is a class. Okay, hello command that implements command. And implements a run method. Run method is intended to actually interact with a shell, so its return object is command outcome, which can contain exit code and so on. So in our case, it will be success, and here, of course, we'll do our hello world thing. Oops. Hello, Bootique. Okay, so now what do we do? Where do we put this command? And this brings us to another feature in Bootique. This is modules. So everything in Boutique is a module. So you assemble your application out of modules, and functionality resides inside modules. Your application is usually also, it's a good pattern to make application a module. So it implements a module, and module it comes to us from Google Juice. So that's a Juice module, even though Boutique adds a few things on top of that. In how it treats module and assembles application out of modules. But basically, it's a Juice module that does all the dependency injection stuff that Juice supports. And here, we will add some code that actually integrates our module with the core module. And this is a very very good feature of Juice that allows you to actually contribute certain things to another module. Say you have a module that implements some algorithm, and you provide some objects to that module and that algorithm can act on them. So in our case, we will be contributing to BQ core module, which is our main module, and it has all the methods. It tells you what you can contribute to it. So it's kind of a plugin system essentially. Contribute commands, binder, add binding to hello command. So we added our command, so now Boutique will know about it, and we will need to also connect this module to our runtime. So here's our amended main method, and we run it again, see if anything happens. We suddenly have hello command. There were no annotations or anything, so it just, as you may have guessed, it used the name of the Java class to generate a command line switch, which can actually be customized, but we don't care about that right now. Let's try invoking the command. So I add this flag to my command line, I do run, and of course, the command got invoked, which wasn't that surprising, but this is how you wire up commands. And actually, it was a good demo, but generally most of the commands that you'll be using daily, they come from some other modules. So you may not be writing your own commands ever, because all you need to do is to run some microservices, for instance, and there is already a module that allows you to do that, and it contains a command. So Boutique is very modular this way. So you combine multiple modules, you get all the commands among those modules, they're exposed in the command line, you can call those commands. So you can create some interesting hybrids that, at the same time, like run, I don't know, database migrations, for instance, with Liquibase, and with one command line switch, and with another start a service. So this way, your Java application can do many things. It becomes a tool. It becomes like a command line tool, really. Now let's do something more interesting than hello world. Let's actually do a microservice, and to do that, we will need to add another module to our dependencies. And that would be a module called Boutique Jersey. If you know, Jersey implements JAX REST specification. JAX REST specification allows you to write REST services. Boutique Jersey. Again, we don't need the version because it's in the BOM. And now we already have JAX REST in our class path, and we can start writing our endpoint. So let's write a simple endpoint, which will also do something primitive like hello world, hello API. Okay, autocomplete without internet. No. Okay, it actually worked, but Eclipse complained about something. So this is our endpoint, and it will have a get method that prints a piece of JSON, essentially our hello world, but wrapped in JSON. Okay, that's good enough. Get, and let's be good HTTP citizens and tell that it produces a certain media type, application JSON. So that's a very simple endpoint, right? How do we added to Bootique. We will use the same approach using contribution. In this case, we will be contributing to a different module. We will be contributing to Jersey module. So Jersey module, contribute resources binder, add binding to hello API. So we hooked up our endpoint, and now we can run it again and see what happens. And initially, it will actually run the last thing that I configured. Okay, let's remove that. Not much has changed. We forgot something. And what we forgot is actually adding Jersey module to Bootique runtime. And we could have written another module call, but instead of doing that, we'll just auto-load it. So we tell that all the modules that appear on the class path will be included in our application. So essentially, your POM will become an assembly descriptor for your modules. So now something different is going to happen. And first, we are getting some login warnings, and but the important part, we got a server command now. So now we can start a server. And Bootique Jersey, it depends on another module internally called Bootique Jetty, and Jetty provides a server command. So we don't need to write our own command here. But let's fix the login first. And login, this kind of demonstrates how we are not opinionated about what you do, because we don't bind any login framework by default, really. So you decide which login framework you use. So one of the standard modules that we provide, though, is Bootique Logback. So it allows you to set up login pretty quickly. I added that dependency, and the warning should go away. OK, great. Now let's actually run the server. Apply, run. Okay, as you see, some Jetty startup happens. And it tells it that it added a servlet called Jersey, and it also listens on port 8080. We haven't done anything, and I swear you, I don't have a plugin that starts Jetty, so it's all in the app. And now we can actually go in the browser and see what's in there. So it actually worked, surprisingly, and. Here you see the log is printed here, so it is really hitting the app. If I reload a few times, I can see more logs. So this is our minimalistic microservice. Everything, we use a bunch of defaults. We generated API, and we can see the output pretty much immediately. Now let's show another feature of Bootique. Another essential feature is its ability to configure everything, and everything that was previously part of your container, but also and things in your app, all in one place. So we've seen that config flag a few times when help was printed, right? So let's use it. Let's create a config. And Bootique supports YAML, JSON. It can support XML pretty easily. So let's use YAML. And here we will configure a few things. We will change Jetty port, and we will also change the path of our endpoint. Let's start with Jetty. So we're configuring modules that is called Jetty. So the top level key is Jetty, and it's connector. And port, let's use port 9000, I don't know. And for Jersey, if I remember everything correctly, it's going to be something like URL pattern for the Jersey servlet. And we change that to, I don't know, BQ. Let it be called Bootique. What's that? Oh, yeah, sharp eyes. All right. Okay, let's stop this one and start using the config flag. And let's run it. So you see it all in the logs. So we have port 9000 already, and we mapped our servlet differently here. So let's reload the old one. It doesn't work. Let's try a new one. So it works now. So So and imagine how useful this is when you develop in microservices. You have maybe dozens of your applications starting from the IDE. You need to run them on different ports, and it is all configured in one place. It's configured together with the application. And one last thing, I don't know if I probably have a few minutes to do the demo, to finish the demo. I want to actually show how, there was no trick, there was no special plugin in Eclipse. That applications that you had, that I had in Eclipse, it's the same applications that you'll end up with when you do a build and make it into a jar file. But to do that, we need a few more things in the POM. So we need a way to build this jar with dependencies, or fat jar. And for that, I also have a bit of code samples. So it's all done using Maven Shade plugin. So really, I'm using Bootique parent only because I don't want to this long configurations that that is needed to build jar with dependencies. So instead, I'm using parent that has all this configuration, and I add a declaration for Shade plugin, and the final thing I need to do is to declare a main class. Main class, and that would be our app. Okay, let's try to build it in the unclean package. Okay, build success. And what happened is that in target, we have two jar files now, the original one, which is a small one, right? And we have jar with dependencies that has dependencies, and hopefully it's runnable. So we run it without arguments. We see now familiar help, and if we do our server config equals test YAML. Address already in use. Okay, I need to stop it in Eclipse. Okay, so it works exactly the same way, really. So that's really runnable Java application in action without any plugins, without any deployment. So just package and run it. Going back to the slides. Bootique was all about. It's actually pretty simple, and you've seen the demo was simple. These are pretty basic things, and that's the whole point. The point of Bootique is to make it easy to start on your project and add any number of dependencies, and let it grow in complexity any way you want. So it's all about modules, configuration, and commands. So here's a list of the modules that we've developed so far. And there are some pretty cool things that you may have never heard about, but that's not the point. The point is that, remember, Bootique was started in December 2015. By now, we have this whole list of modules. It means what? It means that writing a module is really, really easy. If, for instance, if you want JPA, if we're using Apache Cayenne, but if you want JPA, for instance, for your ORM, and you know something about configuring JPA, you can write a module that wraps JPA implementation very easily, really. It will take you somewhere, I don't know, from 20 minutes to a couple of hours, depending on your knowledge of JPA. But we already allow you to write pretty complicated apps, web apps, REST. We support database migrations, login metrics, unit testing, and so on and so forth. Configuration, we've seen it. It allows you to configure various modules you have in the system. And configuration is, it can be one huge YAML file if you want, or it can be partitioned into small YAML files. You just pass multiple config flags. It's actually in the unreleased 0.17 version of Bootique, but it's already there. And you can even package some of them in your jar and then just specify just the overrides, the deltas between, say, some kind of default configuration and, say, your production environment or your QA environment. What happens with configuration inside Bootique? It is loaded into, usually into objects that are factories. And Nothing special about the factory. It's just an object with properties that can be that corresponds to our YAML structure. But its purpose in Bootique usually is to create some kind of services. So we're dealing with dependency injections that instantiates various services for you, and this factory is a way to interface between those services and configuration. And in addition to what is loaded from YAML, it can also take parameters, dependencies from other modules. So in the factory method, you can pass some parameters to it, and you can build some complex services. We've seen commands, and as I mentioned, you won't be writing commands yourself, but sometimes you may. And you can even override this whole thing, and if you don't like help for whatever reason, or you want your default command to be something other than help, you can redefine all that. Testing. So testing is actually an interesting aspect of Boutique that we discovered when we already had a framework. We kind of suspected that Boutique will help us with unit testing, and specifically, I guess, with integration testing. But we were surprised how much it actually helped us, and how many things that were previously not possible became possible. For instance, NHL projects that I mentioned, they have lots of enterprise integration code in them, so they require layers of security. They call your profile. They make REST calls to external services to obtain your profile, for instance, just to run like simple APIs at some app-specific stuff. And we were able to wrap that into this little Boutique runtimes that are executed within the unit test. So what we've seen so far, we've seen how Boutique takes over your main method and actually runs your application. But you can scale it down, so you can make this Boutique runtime just work within your unit test. It doesn't have to kill your JVM at the end. So this way you can start a whole ensemble of services right within your unit test, and then run some tests. Then Boutique will shut it down for you automatically. So we're developing some API for unit testing right now, and we're still experimenting with many things. But even what we have right now is really, changed our lives. So now, the part where we compare it with what you may already know. So Boutique and Java EE. So I have actually a table version of that. Both Boutique and Java EE are actually integration technologies. So at the core lies the need to build complex applications and provide some kind of pattern for building complex applications. Because if you just start with main method and nothing else, you may get lost pretty quickly. How do you connect all the dependencies? How do you make them work in concert? But of course, here the similarities end, because Boutique is WYSIWAR, obviously, it's what you see is what you run, so you interact with your shell directly. And also the style of integration. So in Java EE, again, you are writing plugins, and here we are writing apps. So we control all the modules. So, and as we've seen in the demo, we can change Jetty port, and it's just a simple example. We can actually configure your server just for your application. This was actually a big problem for us when we started before Boutique, when we started migrating to microservices, is the need to maintain two parallel sets of builds, one for our custom Jetty cluster that actually needed to have all the memory parameters and everything just for specific apps. So one app needs that much memory, another app needs less memory. So we need to configure Jetty, then we need to configure our applications, and then we need to match which application goes where. So where is the container for that app? So here it's all in one place. There's unified configuration, and you control all the modules. And my point about everything is programmable, it's actually it is pretty cool in a sense, because for instance, imagine you're inventing some kind of I don't know, new and innovative asynchronous connector for Java web apps, for your REST services. How do you add it to a Java container, really? I mean, you'll have to use their specific API or something, and it will be different in every container. And really, if it goes against serverless specification, for instance, you won't be able to do much with that, really. So you can only extend the existing containers only to a point. There's really some point where you cannot extend them any longer, really. You will be becoming a container provider at this point yourself, really. So Boutique is very pluggable in that way, and it doesn't limit in what you can actually do. So you can do all the things in your app, and you can experiment with really low-level infrastructure things that Java EE really discouraged you to do. So it tried to hide you from those things. And finally, it's a universal Java launcher. So, for instance, you won't be using Jetty to start or Tomcat to start a GUI application, a JavaFX application, for instance. With Boutique, you can. So I guess some of you who are already using Spring Boot, and some people were telling me, like, why don't you start with this slide? Why don't you just like skip the entire presentation and just start here? So it's Boutique versus Spring Boot. And this may be a little contentious at times because, I mean, both tools are essentially solving the same problem. They are inverting the Java EE container and giving you ability to write your applications as applications, not as plugins. So what are the differences then? The differences are in integration style, really, and the consequences of the integration style. So what happens when you go with like Spring Boot style annotations with conditionals or conditional on bean and all those things? And we actually, before we started Boutique, we didn't want to do it. We actually wanted to use something that's out there, and we tried actually Drop Wizard and we tried Spring Boot. And I like Drop Wizard a lot, except that it's more opinionated. Essentially, Spring Boot is a little less opinionated, but it was still painful in a sense that the type of integrations that we wanted to do, they constantly triggered something that was already there and we didn't know it was there. So it would activate some features that unexpectedly, really. So applications ended up like really fragile, and we didn't know what to expect next, you know, when somebody adds something on ClassPass and suddenly something fires up. And the whole thing about uncontrollable dependency injection also. So you have all your beans in your app, and all these things somehow assembled by sprints. There's no order. The only way I think you can control that is by using like exclude annotations and stuff like that. So Boutique and Google Juice that is behind Boutique, it helps you to control your container. It helps you to control how your app is started, what dependencies are there, and if you override something twice, for instance, or whatever, so or you just try to override something without knowing it, it will complain, really. So you will get an error, and then you will go back and decide whether this was intentional or this was unintentional. And it's also what you see is what you run again. I guess at another level, in the sense that only things that are in the POM, those are the things that are in your app. You don't have to exclude anything. There's really no exclude. Just only include. So, in our opinion, it's more predictable, and in our experience, actually. And it scales better to complex apps with lots of dependencies. But again, we are solving the same problem as Spring Boot, I'd say. So what apps is Boutique good for? And I'm tempted to say all kinds of apps. So like any Java app can be written in Boutique, and that's probably true. But I guess some would never try to provide like EGB module, for instance. But potentially you can. You can definitely do microservices. This was our, even though I don't like the word microservices is this whole thing about, you can have like thousands of things that are small apps that live their own lives, and you just sort of moving complexity out of your compiler to your operations. But nevertheless, I mean, so even in a reasonable microservices architectures that doing the right type of partitioning and stuff, Boutique is of course great compared to Java EE, for instance, because it's much easier to write a new app. It takes much less time to set it up and then deploy. So you have an app. It looks the same way. I mean, in a way, I guess there's still Java interpreter in front of it, but it looks the same way as I don't know, Python or like C apps or anything your operations may be familiar with. Apps you distribute to your users, and this is kind of interesting because what I've seen before, and maybe people learned how to do it better these days with containers, but you would get a WAR file from a vendor, and then you have like a list of instructions how to configure it before you can run it. And usually it goes like that. You need to unpack the WAR. You need to go to webinf classes, find some properties file, change something in that properties file, then pack it back, and maybe they supply some build script for that, and then you need to install Tomcat. You need to configure data sources there. Then you need to deploy it to Tomcat. And if that's the software that you actually like let people download over the internet, you probably lost them like at step 2 or 3. With Bootique, you just send a jar, you send a sample YAML, and let them just change the YAML to their liking, and then run. So it just is really just 2 steps, just configure and run. And configure step is really 1 step. I'm thinking all the apps that and the open source apps that actually start some servers like, I don't know, Cassandra or HBase or Spark or whatever. So like anything you might be, if you're thinking about writing something like that in Java and sending it to your users, consider Bootique, because it will provide a very consistent, extendable architecture and very easy for the end users to run and use it. And of course, you can run jobs, JavaFX apps, so you can do GUI apps and quick prototypes, something that Java wasn't very good at, or specifically enterprise Java. Just writing a demo from scratch, it really took lots of time. So that's the apps you can do with Boutique. And a few words before I start taking questions. So Boutique, it's an open source project. We'd like to form a community around it. Maybe we'll go with it. We'll go to Apache Software Foundation if there is, again, interest in the community to do that. And there's lots of benefits to that. We can discuss it offline. So everybody is welcome to join, to participate, to try it out. And we have a website. We have a forum. Of course, we have Twitter, and we have GitHub where you can put a star. We invite anybody interested in building something on top of Boutique or improving this platform to actually come to us, use the forum or Twitter or email me. That's a good start too. And we can discuss it. All right, so I'll take questions now. Any questions? Oh, this one.
Thanks for presentation. I have one question regarding the module term. I mean, in the context of Boutique, when we are talking about a module, is it correct that this is just design time artifact, but not runtime? And if the answer is yes, don't you plan to introduce some kind of engine to manage these modules in runtime?
Okay, yeah, I got the question. So. Yeah, Boutique is not OSGI really. So right now the goal is to allow you to produce this modular and applications and compile them together, and then transit, and you don't change your module composition in runtime. So I guess that answers it. Any more questions? All right, thank you. You can always come to me later. Thank you.